Okay, now let's look at some of the message passing patterns in context of RabbitMQ. RabbitMQ, as we know, is a very popular open source message broker and queuing system. So we'll look at the various patterns that it offers. The most simplest pattern that RabbitMQ offers is the one that is shown on top left of your screen, in which there is only one queue that is shown in red, and then there is a publisher shown by P and a consumer shown by she. In this case, the publisher publishes a message, and this message goes to a queue. A queue is a buffered space wherein the messages are held temporarily until they are consumed by a consumer. So this is a first in first out queue. Any message that is sent by P will be consumed by C in the order in which they are sent. Now this is a very simple use case, and you can think of it as the most basic example of a queue. The next thing that we build on simple named queue is called a work queue. This is also called a task queue because in typical scenarios what happens is the publisher publishes a message, and then that message is consumed by a set of consumers. So for example, let's say that you have a lot of images and you want to resize those images. So then you will have a pool of consumer programs that will take a message from a queue, and then they will resize those messages, and then they will do some further processing. So in this case, the publisher can publish all the images that it reads from, let's say, a local data set, and then sends them to a work queue wherein two consumers in this example can pick those messages one by one, and they can process on these messages. Now what is important to note here is the message acknowledgement part. So typically what happens is that when a publisher sends a message, they can either wait for the acknowledgement to arrive that the consumer has actually processed that particular message, or they can choose to simply ignore that acknowledgement. So acknowledgement is required because there are many cases wherein your consumer can simply die out and the message is still under processing. In those cases, that half processed message is completely lost and the publisher has absolutely no clue as to what happened. So typically message acknowledgement is used wherein the consumer is supposed to send an acknowledgement after the message has been processed, and this basically ensures that all the messages that are published are consumed by at least one consumer process and are processed on them. The other important thing to note here is about the durability of these messages in all. So we talked about the situation when the consumer dies out, but what if, let's say, the RabbitMQ broker itself dies out? In those cases, the messages that are in these queues are lost. So in order to ensure that these messages survive the restart of RabbitMQ, there is a configuration called durability, which ensures that these messages are also written to disk in some sort of a persistent storage, and when the RabbitMQ starts up again, it can read those messages that were not consumed by the consumer and can start publishing or pushing those messages again. In this example of a work queue, the default behavior that RabbitMQ goes is a round robin dispatch, which means that it will push the next message to the next consumer that it contains. So again, in this example, if P is consuming messages with, let's say, content 1, 2, 3, 4, in all likelihood the consumer C1 is going to receive all the odd messages and the consumer C2 is going to receive all the even messages. Now one can imagine that there could be a situation wherein all the odd messages are lightweight messages and all the even messages are heavyweight messages, which means that the consumer C1 is going to consume and process messages much faster than the consumer C2. And if we took any snapshot after this process has started, we will find that consumer C2 has a backlog of messages that it needs to process, while C1 is pretty much free because it processes these messages in very fast time. So in order to ensure that the messages delivery is happening at an even rate, there is another kind of dispatch which is called as the fair dispatch. In fair dispatch, RabbitMQ looks at the existing backlog of the customers and decides to move the messages to a different consumer. And that basically ensures that all your consumers have almost equal load distribution. Now, let's look at a third case wherein we introduce the exchange in addition to the queues and the publisher subscriber. Now, exchange is so what happens with exchange is that the producer sends to exchange and exchange pushes it to queue. Now, how does exchange do that? This depends on the type of exchange. So in RabbitMQ, there are 5 types of exchanges. For example, there is a direct exchange, there is a topic exchange, there is a header, and there is a fan out exchange. So there are 4 types of exchanges. The most basic one is a direct exchange, wherein a direct exchange delivers messages to queues based on a message routing key. So with RabbitMQ, whenever you send a message, you have this option of specifying a routing key. Think of routing key as an address that the exchange is using to decide how to route the messages. So in this direct exchange example that we see here, this is an example wherein the publisher is publishing logs of different level, and the exchange has been configured to send the messages that have the routing key of error to a different queue, whereas the messages that contain routing key as info or error or warning can go to a different queue altogether. And then there are different consumers who are acting on these 2 different queues. And let's say in this case, we would want to write the error messages into the disk, and we would want to write every other messages to the std out or std err, and that's where this kind of a direct exchange becomes very helpful. The thing with direct exchange is that it still has some sort of a restriction in terms of how the exchange routes it, because there are specific words that are used as the routing keys. To add more flexibility to that, RabbitMQ has something called as a topic exchange. Now, topic exchange route messages to queues based on wildcard matches between the routing key and the routing pattern, which is specified by the queue binding. So in this topic exchange example, we can see that the topic routing key contains wildcards, and these wildcards are pretty similar to the regular expressions that we use, but a little but we don't use all the regular expressions that are there. So there are only a limited set of wildcard characters that are allowed, and based on that, the topic exchange is able to provide a little more flexibility on top of the direct exchange. Now, there is a third type of exchange which is called a fan out exchange, and the fan out exchange copies and routes a received message to all queues that are bound to it, regardless of routing keys or pattern matching, as with direct and topic exchanges. So fan out is the example that is shown on the left hand side, the most bottom image that we see. And in this example, any message that is sent by the publisher will go on to all the consumers in this case. There is another type of exchange called as the header exchange. A header exchange routes messages based on arguments containing headers and optional values. Header exchanges are very similar to topic exchange, but they route message based on header values instead of routing keys. And this again can be useful in certain situations wherein the message header has the conditions or the or the arguments that decide how this message is going to be routed. Now, the other type of exchange pattern that RabbitMQ provides is called a remote procedure call. So in all the other exchange types, direct, topic, or fan out, for example, a message is directly passed to a particular consumer or a set of consumers. But what if instead of a message, we want to, let's say, call a function present at a different server by passing certain arguments to that function? Now, that is where a remote procedure call message passing pattern is useful. In this case, the client is able to send the parameters of the function to RabbitMQ, and then RabbitMQ internally creates different kinds of queues that enables a remote server to execute that particular function call with the parameters provided by the client, and then return the value of that function on over to the client. Now, this could also be very useful in cases wherein you want to call a particular function and you don't want to really write it or implement it at your own client end. However, remote procedure call is something that is not very encouraged because of many reasons. The most important reason being that there are certain vulnerabilities that might occur as a result of RPC. The other thing is that it might be very confusing for the developers to understand if the function call that is being made is a local function call or a remote procedure call, because remote procedure call involves network and transfer of data from the client to the server. Those function calls could take a lot of time to process and get the data back. So this is all provided, but this is something that has to be used with very caution when you know that RPC is being used.